Mars just broke the laws of physics, and NASA can't explain it. For 3 days straight, something on the Martian surface did what scientists said was absolutely impossible. It moved. Not from wind, not from a landslide, not from any natural force we understand. It moved on its own, against gravity, against everything we know about planetary science. And when the data came back to Earth, researchers at JPL went silent, because the implications of what they were seeing didn't just challenge one theory, it challenged the entire foundation of how we understand dead planets. This isn't about water anymore. This isn't about ancient microbes frozen in ice. This is about something happening right now, something active, something that has turned Mars from a museum of the past into a laboratory of the impossible. And if what the instruments detected is real, then we're not just looking at Mars wrong, we're looking at the entire solar system wrong. Let me show you what happened. It started on October 14, 2024. The Mars Reconnaissance Orbiter was performing routine imaging over a region called Cerberus Fossae, a massive crack system near the Martian equator. These are ancient fractures in the crust, formed billions of years ago when tectonic forces ripped the surface apart. Nothing special. NASA has photographed this area hundreds of times. But when the latest image came through, something was different. A boulder, roughly 8 meters across, sitting at the bottom of a shallow crater. The team cross-referenced older images from the same location. 6 months earlier, that boulder wasn't there. It had been 340 meters uphill, on the opposite side of the crater rim. Now here's where it gets strange. The boulder didn't roll down. It rolled up. At first, mission scientists assumed it was a mistake, a mislabeled coordinate, a stitching error in the imaging software. But after 3 weeks of verification, the conclusion was undeniable. That rock had moved upward against the slope of the crater, against gravity. And it wasn't alone. Once researchers knew what to look for, they started finding more. In Valles Marineris, the largest canyon system in the solar system, orbital cameras captured another anomaly, a cluster of 7 boulders arranged in a nearly perfect arc. Previous imagery from 14 months prior showed those same rocks scattered randomly across a 200-meter stretch. Something had moved them. Something had arranged them. In Noctis Labyrinthus, a chaotic maze of intersecting valleys, a 12-meter rock appeared to have shifted 89 meters perpendicular to any downward slope, not sliding with gravity, not tumbling from an impact, moving sideways across flat terrain. And then came the kicker. HiRISE, the most powerful camera ever sent to another planet, captured time-lapse sequences of one specific boulder in real time. Over 72 hours, it moved 4.3 meters. Slowly, steadily, deliberately. NASA released a carefully worded statement, anomalous surface displacement events under investigation. Translation, we have no idea what's happening. The scientific community exploded. Every major planetary research lab on Earth demanded access to the raw data, and when they got it, the theories started flying. Theory 1. Thermal expansion. Mars has wild temperature swings. Daytime temps can hit 20 degrees Celsius. At night, they plunge to -80. Could the rocks be expanding and contracting, essentially walking across the surface? Possible, but the math doesn't work. The expansion would be microscopic, not enough to move an 8-ton boulder uphill. Theory 2. Ice sublimation. Frozen CO2 beneath the rocks could be turning directly into gas, creating pressure that lifts and shifts them. We've seen this with smaller pebbles. Could it scale up? also possible, but these boulders moved during Martian summer when surface ice is nearly non-existent, and the motion was too controlled, too directional. Sublimation would cause chaotic random jumps, not slow, steady displacement. Theory 3. Marsquakes. Seismic activity could be shaking the rocks into new positions. Except InSight's seismometer, which was still active during some of these movements, detected nothing, zero seismic activity during the displacement windows. Theory 4. Dust devils. Mars has powerful whirlwinds that can move small debris, but these aren't pebbles, these are multi-ton boulders. The strongest Martian dust devil ever recorded maxed out at 90 kilometers per hour. That's not enough force to budge a rock this size, let alone push it uphill. Every conventional explanation failed, and then a researcher at the University of Arizona noticed something nobody else had. The moving boulders weren't random, they were all magnetized. Mars has a strange relationship with magnetism. Billions of years ago, it had a global magnetic field just like Earth, a protective bubble generated by a molten iron core spinning deep underground. But around 4 billion years ago, the core cooled and solidified. The magnetic field collapsed. What's left today are fossilized remnants, patches of ancient magnetism locked into rocks when Mars was still geologically active. These magnetic anomalies are scattered across the southern highlands like fingerprints of a dead dynamo, and every single moving boulder sits directly on top of one of these magnetic hotspots. Coincidence? Maybe. But when researchers analyzed the mineral composition of the boulders using spectroscopy, they found something jaw-dropping. These rocks contain massive concentrations of magnetite, iron oxide, the same mineral used in compass needles. These boulders are essentially giant natural magnets sitting on top of ancient magnetic fields. But here's the problem. A static magnetic field can't move an object. It can attract or repel, but once the object settles into equilibrium, it stops. To create continuous motion, you need a changing magnetic field, a fluctuation, a pulse. And that's exactly what NASA's MAVEN orbiter detected. MAVEN has been studying Mars's upper atmosphere since 2014, measuring solar wind interactions, atmospheric escape, magnetic field variations, routine stuff. But when scientists went back and correlated MAVEN's magnetic field data with the timestamps of the boulder movements, they found something impossible. During each displacement event, MAVEN recorded sudden, localized surges in magnetic field strength, short bursts, lasting only a few hours, concentrated directly over Cerberus fossae, Valles Marineris, Noctis labyrinthus, the exact locations where the boulders moved. These magnetic pulses weren't coming from space. They weren't solar flares or cosmic radiation. They were coming from below the surface. Mars' supposedly dead magnetic field was flickering back to life. Now, this shouldn't be possible. When a planetary core solidifies, it's done. No more convection, no more dynamo, no more magnetic field generation. You can't just restart a frozen engine, unless the core isn't completely frozen. Earth's core has 2 layers, a solid inner core and a liquid outer core. The liquid layer is what creates our magnetic field through convection currents. Mars is smaller, cooled faster, and scientists have always assumed its core is solidified entirely. But what if they were wrong? What if Mars has a thin liquid layer still sloshing around down there? Not enough to create a global field, but enough to generate localized pulses under the right conditions. InSight's seismic data already suggested Mars has a partially molten core. It detected low-velocity zones consistent with liquid iron. Scientists dismissed it as residual heat, the last dying gasps of a cooling planet. But if that liquid core is responding to something, tidal forces from Phobos, pressure changes from deep reservoirs, even solar magnetic field interactions, it could be generating intermittent magnetic pulses. And those pulses could be strong enough to move magnetized boulders on the surface. It sounds insane, but the data fits. If Mars's core is still partially active, if it's generating magnetic field fluctuations, then everything changes. A magnetic field protects atmospheres. Earth's magnetosphere shields us from solar wind that would otherwise strip away our air molecule by molecule. Mars lost its atmosphere because it lost this shield. But if Mars can still generate even weak, localized magnetic fields, it means the planet isn't as dead as we thought. It means there's still energy down there, still heat, still motion. And if there's motion, there could be volcanism, there could be hydrothermal systems, there could be chemistry, there could be environments where life doesn't just survive, but thrives. The moving boulders aren't just a curiosity, they're evidence of an active planet. And here's where it gets really wild. If Mars is generating magnetic pulses, could it eventually regenerate a full magnetic field? Could the planet be in the middle of a magnetic reversal like Earth experiences every few 100,000 years? Probably not anytime soon. We're talking millions of years if it happens at all. But the possibility alone is staggering. It would mean Mars could, in theory, reclaim its atmosphere, retain water, become habitable again. Not in our lifetimes, not in 1,000 lifetimes, but on geological timescales, Mars might not be a dying world, it might be a sleeping one. NASA is now redirecting resources. New missions are being planned to deploy magnetometers directly on the surface near Cerberus fossae. Drones equipped with magnetic sensors will fly low over the anomaly zones, and future rovers will carry equipment to measure subsurface magnetic field variations in real time. Because if this is real, if Mars is magnetically reawakening, then the timeline for human colonization just got a lot more complicated. We're not landing on a static rock, we're landing on a world that's still evolving. The boulders are still moving. As of last week, HiRISE captured another displacement. A 6-meter rock shifted 11 meters overnight. Mars isn't just doing something impossible, it's doing it repeatedly, consistently, and we have no idea when it will stop or why it started. For decades, we looked at Mars as a case study in planetary death, a cautionary tale of what happens when a world loses its magnetic field, its atmosphere, its water, a glimpse into Earth's potential future. But maybe we had it backwards. Maybe Mars isn't showing us how planets die, maybe it's showing us how they come back to life. The red planet just moved a mountain, and in doing so, it moved science. If you want to follow this story as it develops, subscribe, because something impossible just became real, and the implications are only beginning.